Hi everyone. So we're in the last section to topic 8, which is the greenhouse effect, and we're going to start with something called the climate balance model. We're going to look at how greenhouse gases work to heat the atmosphere. In order to do that, we need to work out how the temperature of the atmosphere is controlled and balanced. So we're going to be looking at a climate control model. Now, the first thing to understand is that there are not that many greenhouse gases. The most important four that we need to consider are water vapor, carbon dioxide, methane, and nitrous oxide. So these are the 4 gases that are present in the atmosphere which contribute to this greenhouse effect. This effect has a very bad reputation. It's actually a good thing. Without it, the Earth would be an extremely cold place. A naturally or beneficial greenhouse effect is useful for us because if we did not have this atmosphere, we would be about 30 degrees cooler, and so the Earth would not be able to sustain life. The fact that our atmosphere contains gases that can absorb heat and maintain a stable atmosphere is actually what contributes to life on the planet. The ideal situation is to constantly maintain a balanced atmospheric temperature. So if the Earth receives an average of 1.74 times 10 to the 17 joules of radiated energy from the sun every second, then what we really need to do is make sure that we get rid of, or we reflect or transfer that much energy out. We need to maintain a thermal equilibrium and ensure that the average temperature will remain constant. So this energy in has to balance the amount of energy that is radiated away from the atmosphere. If the Earth radiates less, then the temperature will increase. If the Earth radiates more, then our temperature will go down. In order to understand this climate balance model, we need to think about the relationship between the molecules of these greenhouse gases and the heat itself. What do we mean by the sun is receiving heat? We actually mean that the sun is receiving infrared energy. If we think back to when we looked at conduction, convection, and radiation, the only way that we can get energy from the sun is by radiation. So what is the relationship between that infrared energy and these greenhouse molecules? Well, all gas molecules oscillate. Molecules of greenhouse gases, they oscillate at the same frequency as infrared radiation. Greenhouse gases, they absorb this infrared radiation because there is actually a very, very special relationship between the molecules themselves and the frequency of that infrared. It's something called resonance, which isn't actually on your syllabus. But basically, at that particular frequency, they absorb and re-emit. Now, those molecules re-radiate the energy at the same wavelength, but in random directions, so that some of the energy that was previously moving away from the Earth is now redirected back towards the Earth's planet, or the Earth's surface, sorry. So the energy is coming in, and it should be bouncing straight back out. But it gets absorbed by the atmosphere and it gets re-radiated in ways that actually mean that the Earth itself starts to heat up. This diagram gives you a bit of a visual relationship between the range of different frequencies, okay, that we get that's transmitted by the atmosphere. So if we have a look at the infrared range here, and we look at the visible range and ultraviolet here, this gives you a measure of the amount of emission. Now, these are all the different gases, water vapor. And what this is telling you is water vapor likes to absorb this whole range of frequencies here, right? And then a little bit in the high range, right? So water vapor will absorb these frequencies. Carbon dioxide will absorb this range, which is actually quite an intense range. Oxygen and ozone, nothing. UV, if anything. So I'm not interested in that. Methane, again, in that infrared range. Nitrous oxide is in that infrared range. So all of these greenhouse gases, what they do is they absorb this or these frequencies, which are in the infrared. They absorb and re-emit, and that actually causes the realignment of the radiation towards the Earth. You actually only need a really basic understanding of it, but those of you who do chemistry might want to take this further. I'd like you to watch this video when I finish my explanation, because it will take you a little bit further. Now, once you have an understanding of this idea of absorption and re-emission of infrared, we can look at the entire energy flow situation, where you've got the energy coming in, your incoming solar radiation, and you've got all that radiation that's absorbed by the atmosphere. And because it's re-radiated, some of it, what we call back radiation, is then absorbed by the surface of the Earth. The surface of the Earth is a hot body then, and therefore will re-emits, because anything that is at a high temperature, you should understand now, anything that's at a high temperature will emit a certain amount of energy. That would be your black body radiation curves. So the Earth, because it's being warmed up by this radiation, is now re-emitting some of that radiation back. You also get reflection. So in addition to the reflection, you get this absorption and radiation, and then you also get some radiation from the atmosphere. The whole thing should actually balance, but it doesn't. At the moment, we're definitely getting more coming in than we are sending out. If the total heat in equals the total heat out, then the temperature of the Earth stays constant. There's a couple of backup videos that I'd like you to watch. This one and this one. This one goes into some really, really nice detail, and there are some questions that go with it. Once you've understood the model, I'd like you to answer these questions on the assignment. In the next lesson, we'll actually look at why the temperature of the Earth is increasing and why this climate balance model is just not working out.